Hello students, in this video we are going to learn about the chemical properties of acid. Previously we have learned the indicators and also the different colors they give when they are coming in contact with an acid and base. We have learned about the physical properties of acid. We also have learned what are mineral acid, organic acid, how acids are classified to be strong and weak. We have seen several such examples of such acids. Okay, today we are going to deal about some chemical reactions that includes the chemical property of acid. The first chemical reaction that we are going to learn is that metal reacts with acid to give us salt plus hydrogen. Okay, when a particular metal reacts with acid, they give us a particular salt and hydrogen. This is why the particular acids are not kept in metal containers. They are kept in glass utensils or glass beakers. Okay, so let us see some examples of this reaction where a metal reacts with an acid to give us salt and hydrogen gas. Let us take an example, say zinc, when it reacts with H2SO4, they gives us zinc sulfate plus hydrogen gas. They gives us zinc sulfate and hydrogen gas. When a solid metal reacts with sulfuric acid, they give you a salt and hydrogen gas. Let us take more one example, like magnesium is also a solid metal. When it reacts with say HCl, okay, they give out magnesium chloride, MgCl2, that is solid, with the liberation of hydrogen gas. Now my friends, in this reaction we can see the liberation of hydrogen gas. They can ask you a question that how we will understand that a particular metal liberates hydrogen gas, or the gas that is liberated is hydrogen. How we will understand? We know hydrogen is one of the lightest gas. Okay, let us see one of the experiments. We are taking a test tube. Fitted with a cork. Okay, in this cork we make two holes. One of the hole is for a thistle funnel that is used to pour acid within the container. Before fitting the cork, we place some granules of metals, say zinc. We place some granules of metals in this test tube and then we fit the cork. When this particular acid, say particular acid is poured in this particular thistle funnel, it comes in contact with your zinc. When the chemical reaction occurs of a metal and acid, they leads to the liberation of hydrogen gas. The gas that will be liberated, it passes through this delivery tube and is passed into a beaker, that contains soap water. So in this beaker we are taking soap water. We know soap water causes soap bubbles. So as the particular reaction occurs, hydrogen gas, a particular gas, it comes out of this delivery tube and passes into this water, soap water. Okay, this soap water causes formation of soap bubbles, and as hydrogen gas is lighter, it goes up. When we bring a candle near to this bubble and try to burn the bubble, the gas inside it burns with a pop sound. It is because the gas that is used is hydrogen. The gas that is liberated is hydrogen. So let us come again. Metal, when they reacts with your acid, they give to the formation of a salt and hydrogen. A particular more reactive metal displaces hydrogen and leads to the formation of a salt and hydrogen. Okay, now let us see the experimental setup, how we will identify that the gas that is liberated is hydrogen. When this particular reaction is taken in such a setup, when we are seeing the gas that is evolved is collected and passed into a soap water, we will see that the soap bubbles containing hydrogen gas, when burnt with a candle bringing near to it, we will observe a pop sound. Okay, this pop sound is because of the hydrogen gas. Clear? Coming up to the next chemical equation, where we will see a metal carbonate or bicarbonate. I hope you know the particular radical formula. This is CO3 2 minus and this is HCO3 minus. When they react with an acid, they liberate salt, carbon dioxide and water. Okay, this is the second chemical reaction that we are learning. When a metal carbonate or bicarbonate is reacted with acid, they liberate salt, carbon dioxide and water. Let us see some examples. When we will take, say, example Na2CO3, this is sodium carbonate. When reacts with H2SO4, they leads to the formation of Na2CO3 plus Na2SO4 plus CO2 plus H2O. Okay. Now in this reaction, when sodium carbonate reacts with sulfuric acid, it leads to the formation of salt, Na2SO4 and CO2 gas and water. Let us see a bicarbonate NaHCO3. When reacted with, say, HCl, they leads to the formation of NaCl plus CO2 plus H2O. Okay. Now, in this both reactions, whether we take a carbonate or a bicarbonate, they react with an acid to give us salt, carbon dioxide and water. Now, the question arises, how we will identify that the gas that is liberated in is carbon dioxide. So what we do, we take the same setup, okay, and we pass carbon dioxide into a lime water solution. Let us take the setup. We are taking the same setup, okay, where we are fitting the particular test tube, keeping some carbonate salts, keeping some carbonates in this, say, Na2CO3 is kept in this vessel, and we pour acid with the help of a thistle funnel. Acid is poured by the help of a thistle funnel, okay, and it reacts over here. The gas that will be evolved is delivered into a container containing lime water, So lime water is having a formula CaOH2. This lime water, when the passage of carbon dioxide occurs, it turns milky. Why does it happen? We have to see the chemical reaction over here. Okay, in this particular part, we will see that the carbon hydroxide that is present in lime water reacts with the carbon dioxide in this way. CaOH2 reacts with CO2 with the formation of CaCO3, calcium carbonate, which is white in color, with the liberation of water. Okay, so this is why this particular lime water solution turns white, because of the formation of calcium carbonate. Okay, now again, excess of carbon dioxide is passed into this solution. What happens? This CaCO3, when excess of CO2 is passed in the presence of water, we see the formation of CaHCO3(2), calcium bicarbonate, which is again soluble, and hence again the milky solution turns colorless. Let us repeat this particular reaction. When metal carbonate or bicarbonate, they react with an acid, they give out salt, carbon dioxide and water. We have taken two examples, sodium carbonate and sodium bicarbonate. When they react with particular acid, they liberate out salt, sodium sulfate, sodium chloride as per the particular acid used, and there is a liberation of carbon dioxide and water. Why we how we identify that the particular gas that is evolved is carbon dioxide? We take this setup. In this setup, we have taken a test tube where we have previously filled Na2CO3 in this test tube, fitted with a airtight cord, where a thistle funnel is pouring acid into it. By the chemical reaction that is occurring, a gas is evolved. The gas is passed through the delivery tube into a lime water solution that has a chemical formula CaOH2. Now this CaOH2 on the passage of carbon dioxide turns milky in color. This occurs because of this particular reaction. This is very important. This calcium hydroxide in the presence of carbon dioxide, they form calcium carbonate, which is white in color and hence turns milky. But if excess of carbon dioxide is passed into the solution, this calcium carbonate with excess of carbon dioxide, they again form calcium bicarbonate, which is soluble in water, and the milky solution again turns colorless.